Getting things started with Big Elliot. All right, happy Wednesday, everybody, and I hope you're having a great rainy Wednesday day. Raining is just happens to be what it is doing. Not saying that rain means you're going to be happy. It's just the way it is. Okay, so this is what we are going to be doing today. Sorry, I'm a little discombobulated here. We have properties of exponents is what we're going to be learning. Now, this will be the last video lesson until I think you're going to have another video that you're going to need to watch on November 1st. Let me just get a quick confirmation on that. Okay, let's see. I'm looking at this Excel file here with our calendar. 1, 2, 3 more practice with exponents. Yes, I'll have a last video until October 31st, which means that on Monday night during Halloween, I'll have another video for you. With that said, I'll try to get that video made on Friday so that you can do the video over the weekend, so that on Monday night maybe you can have some fun collecting some candy instead of watching these videos. The reason this is just going to be the singular video until for the next 3-4 days, if we look at our topic list, what I'm about to teach you, the properties of exponents. These properties cover these 4 objectives. Product quotient property, the -0 exponents, the power properties, and then finally, multi-step problems, using them all together. So my lesson is basically going to cover all 3 of these, which leads us into this 4th one. So tonight's lesson is going to be a little bit longer than the normal one, but just a lot of valuable stuff. And then after this, there won't be another lesson for a while. Okay, so for properties of exponents. Let's see, let's make the list here. First one, let's say that I had, and these are the first 2, the product and quotient property. Here's the product property, a to the m times a to the n. Now, when I think of these, it helps me to think of a real life example, like if this was x squared times x cubed. Where you got the same variable for the base, and then the exponent, we have different variables. Well, if I think about this, x squared is x times x cubed is x times x times x. So this is essentially x times x times x times x times x. This is essentially x to the 5th power. Well, what did we do to 2 and 3 to get 5? We added them. So that's a to the m plus n. That's the product property. Next to the quotient property, so using division. So what if it's a to the m divided by a to the n? Well, that would be having something like x to the 5 divided by x squared. And if we think about that, that's x times x times x times x times x divided by x times x. We have stuff on the numerator and the denominator held together by multiplication, so they cancel out, and you end up with x cubed. All right, well, what did we do to the 5 and the 2 to end up with a 3? We subtracted. 5 minus 2 is 3. So this is the equivalent, oops, I wrote that wrong, a to the m minus n. We subtract the exponents. Okay, so that's the product and the quotient property. Next is negative exponents and 0 exponents. So what happens with a to the negative n, and what happens with a to the 0? And the best way to explain this, in my opinion, is I actually have explained it. Let's make a table of values for x and 3 to the x. Well, if I do 1, 3 to the 1 is 3. If I do 2, 3 to the 2 is 9. If I do 3, 3 times 3 times 3, 3 to the 3, that's 27. So we've done these problems before where to get from 3 to 9, we're multiplying by 3 over 1. Which means if we're going to travel in the other direction, we need to multiply by its reciprocal, which is 1 over 3. So if I multiply 3 by 1 over 3, I end up with 1. And following this pattern, 3, 2, 1, 0, that means 3 to the 0 is equal to 1. And that's going to be the true for anything to the 0 power. A stands for anything. Anything to the 0 is always equal to 1. Well, if we continue this pattern, negative 1, if you multiply 1 by 1/3, you get 1/3. Or negative 2, 1/3 times 1/3 is 1/9. Well, I noticed that 3 squared was 9, so 3 to the negative 2 is 1 over 9. So using that idea, a to the negative n is equal to 1 over a to the positive n. So we moved the exponent business to the denominator, making it positive. It works the other way too. So if you had 1 over a to the negative n, that's equal to a to the positive n. Or another way of looking at it, same idea, let's say that I had a over b to the negative n. I can essentially reciprocate what's on the inside here, which gives me b over a, and because I reciprocated the b over a, it now comes to the positive n. So when you think about this, this is the reciprocal, this is the reciprocal, it's all reciprocal stuff. So that's objective 2b, the simplifying negative and 0 exponents. Then the third one is power properties. So that one would be a to the m raised to the power of n. Well, if I think about a real life example, x squared raised to the third power, well, that's x squared times x squared times x squared. And if I use that product property from earlier of adding these exponents together, I end up with x to the 6. So what did you do with the 2 and the 3? You multiplied them. So this is equal to a to the m times n. Last rule for this set, what if it's more than one letter? So I have a, b, 2 separate numbers inside the parentheses that's being raised to the n power. Well, it's a times b to the n. What you need to do is you just need to make sure that this exponent gets applied to both of them. And this is currently a to the 1 and b to the 1. So 1 times n is n, so a to the n, and 1 times n is n, so b to the n. Same thing if it's a fraction. If it's a over b to the n, that's just like applying the n exponent to the a and to the b, so it would be a to the n over b to the n. And those are the properties of exponents. So students, please make sure that you have this list of properties of exponents. If you haven't paid attention to this lesson, at the very least, have this list with all those different properties, because this is the properties I'm going to use in part 2 of this lesson, examples. Last but not least, all of these rules are in your book, and if you want to go to page 259 in your Algebra 2 book, they'll talk a little bit more about these properties, maybe present them in a way that's easier for you to understand, I'm not sure. But with that said, we have gone over the properties of exponents, so that concludes part 1 of this lesson. Part 2 is going to be coming by in just a couple minutes, and that's going to be doing examples. So have yourselves a great day, everybody, and I will see you the next time I see you. Bye-bye.